In this video, we're going to talk about the graphs of sine and cosine. So on this first slide, I want to show you a GIF, and yes, I'm a GIF, not GIF kind of person. I want to show you a GIF in just a moment, but I want to point out some things that are happening here. So the whole story behind the graphs of sine and cosine, etc., come from the unit circle. So here in green is our unit circle, and as we know, if I was to find a degree measurement on here, let's say it's 45 degrees or pi over 4, I know for sine that's the square root of 2 over 2, and it's the same for cosine. So if I was to graph that as a coordinate, so if I took pi over 4, let's say, which might be like right here, and its output value, its y value, would give me rad 2 over 2. The same thing would happen on cosine. But as you move around the circle, we know that not every angle is going to have the same value for sine and cosine. For example, 30 degrees, sine is 1/2, cosine is rad 3 over 2. Those two things are different. So essentially what happens, and what mathematicians have done with the unit circle, is they took every angle, the ones that we happen to know and the ones that aren't so pretty, and they mapped the output value to create a two-dimensional curve. So the x-axis is the angle measure, typically in radians, and the y-axis is the output, or that x or y on your unit circle. So when I play this GIF, what's going to happen is something called the unwrapping function. So it's literally unwrapping this circle and laying it out in a curve that is technically the same length as that unit circle there, and creating a two-dimensional graph for sine and cosine separately. So notice this thing is going around the unit circle, and it is mapping the sine and cosine values. Now I'll let that play for a little bit. It's very melodic. It's really beautiful and tranquil looking to me, maybe not to you. You could always look up unwrapping GIFs on the internet and you'll see fancy things like this. So I wanted to show that to you so you have an idea of where these graphs actually come from. So like I said in today's video, we're going to focus on sine and cosine, and with any function you can use transformations to manipulate that function, so it doesn't necessarily look like the parent function. So there are 4 things that you can manipulate in a sinusoidal curve. So they're labeled here, and they're commonly known as A, B, C, and D, and they have these places here, so they go in alphabetical order, which is nice. So A stands for amplitude, and we're going to go over all of these things in the next couple videos, but I just want you to know what they're called. And B, the thing right in front of the X, is the frequency. C is something we call phase shift, or a horizontal shift, so it shifts along the x-axis. And this thing out here, sometimes it's here, it can be like 2 plus something of sine, or it can be at the end. That's called the vertical shift, so that's going to move your function up and down on the y-axis. Today, in this video, we're going to focus mostly on amplitude and frequency. The first thing I want to go over is what amplitude is. So this is the parent function for the sine curve. Notice that it starts at 0, starts at the origin, goes up, hits a peak at pi over 2 comma 1, comes back down, hits the x-axis again at pi comma 0, hits down at 3 pi over 2 comma negative 1 to give us our minimum in this cycle, and then goes back up to the x-axis at 2 pi comma 0. So that's a full cycle. Sine has to go up, come back down to the x-axis, go down, and then come back up. So amplitude relies on something called the midline. So that's this line right here, and it doesn't always have to be the x-axis. So that would be our shift of the vertical shift, that d value. But amplitude is something that is measured from the midline, so that's crossing straight through that function right there. So amplitude is essentially defined as the distance, the max or min point, so this being the max and that being the midpoint of your sinusoidal curve, is from the midline. So remember, distance is always the absolute value. Distance is always positive. So even if your number here was negative, your amplitude would always be positive because it's distance. So I notice that I go from 0 to 1 here and 0 to negative 1 here. So taking the amplitude, taking the absolute value, that gives me 1. So the standard amplitude for sine, cosine, tangent, etc. is going to be 1. But most often they're manipulated to be a different number. So the next thing, that b value, is called frequency. So that is the number of cycles that function completes in a standard period. So a standard period of sine and cosine is 2 pi. So it has to go up, come back down, and then hit 2 pi. That's the typical cycle. Now, if that number changes to be something other than 1, that means it completes however much of a cycle in 2 pi. So if that was a 2, that would mean it would create, or it would complete 2 cycles in 2 pi. So it would be more frequent. And if that number was less than 1, let's say it was like 1/4, it would only complete a fourth of a cycle in 2 pi. So the way that we figure out what the actual period of that function is going to be, if that number b is different, I take the standard period, which is 2 pi for sine and cosine, and I divide it by that b value. So that's going to tell me what the period actually is. So that means how long that actual cycle is. So again, if that b value is anything other than 1, you need to do 2 pi over b to figure out the actual period. And now I want to quickly show you how amplitude and frequency look on a cosine curve. So obviously, cosine and sine are different functions, and the typical cosine curve looks like this shape. So where sine starts at the origin and goes up, cosine starts at typically 0, 1 and goes down. So it goes down, hits the x-axis at pi over 2, hits its absolute minimum at pi, -1, comes back up to the x-axis at 3 pi over 2, and then hits its second maximum at 2 pi, 1. So it makes this kind of U shape here. And now amplitude is the same definition. It's the distance from the midline. And the midline here cuts this function in half. It's still the x-axis, but again, to remind you that if you have this d value here that's not 0, so if it was like +1, the midline would go up 1. If it was -5, the midline would go down 5. So keep that in mind. But the distance from the midline on a standard graph is still 1, much like the sine curve, because the distance from the midline to the maximum here are both 1, and the distance from the midline to the absolute minimum is also 1. So keep in mind that your midline, the distance to the max or min, has to be the same value. So if they're not, for whatever reason, rethink your midline. Just a tip. And now let's talk about the frequency of a cosine curve. So notice that the standard period for sine and for cosine is 2 pi, and of course sine and cosine look different from one another, but one cycle of a cosine curve starts up here, comes all the way down, and comes back up, so it makes that U shape. So in order to figure out a period that is not 2 pi, meaning if you have a different b value here, you're going to do that calculation that you did with sine, which was that 2 pi over b. So that doesn't change for sine or for cosine. So now let's practice using a function determining the amplitude and period of two different functions. So let's start with this one. So the first thing that I always want to do is identify any a, b, c, and d values. So here I've identified the number in front of sine to be a, which tells me that my amplitude, the absolute value of 3, is 3. So from the midline, it's going to go up 3 and down 3. And now I need to figure out my period, so I'm going to take this b value and put it underneath 2 pi. So I have period is equal to 2 pi over b, and if b is 2, that becomes 2 pi divided by 2, which if you simplify it is pi. So that means that the frequency is 2. So that function is going to complete 2 full cycles in a standard period. So it'll look like it's going a little bit faster. So now let's try to figure out the amplitude and period for this cosine function. So first thing I'm going to do here is identify my a and b values. So a is -4 and b is 1/2. And so the amplitude is the absolute value of that -4, which means that the amplitude, or the distance from the midline, is for up and or down. But that negative will affect how that graph will look, and we'll take a look at that in a little bit. So the period is 2 pi over b, and so 2 pi over 1/2, there's a couple things you could do there to figure out what that is simplified. One thing you can do is multiply by the reciprocal here to cancel out your denominator. And so that's 2 over 1. So 2 pi times 2 over 1 is 4 pi. So what that means when the period is 4 pi is that you are only going to see 1/2 of a cycle in the standard period of 2 pi. So that means, for example, in that function, you have a pretty frequent looking graph. This one is going to take a little bit longer to complete its full cycle of 4 pi. So here's where the fun begins. Let's graph that function that we had in the previous slide. So that is y equals 3 sine 2x. And so two things we already found, but the two things that I would do if this was a new function was to find the amplitude and the period. So the amplitude's 3, the period is pi. And so the next thing I want to do is start thinking about what my graph will look like and how many increments I want to graph this thing in. So here's how I approach it. And now there's a ton of different ways you can graph this function, but here's how I think about it. So there are 5 key points in one cycle. So that might mean that I have something right here and then 4 more for one cycle. And if I need to graph 2 cycles, that means that I'm going to have more. But if I graph the first 5 key points, I can then just duplicate them as many times as needed. So here's what I mean. So when I start to label my axes, my y-axis is a little bit easier because I know with the amplitude it's going to go up to +3 and down to -3 because I don't have a plus or minus something at the end. I don't have that d value, so I know the midline is going to be my x-axis. And so that was kind of easy to label here. But given your graph that you are using or paper that you're graphing on, whatever it is, I have about 30 squares here, and I know that if one cycle has 5 key points, between those 5 key points I'm going to have 1, 2, 3, 4 like little pieces. So I know that in 2 cycles there are going to be 8 increments, and so 30 divided by 8, I can fit them in every 3. If you like to do that, if you are a perfectionist like me, you will do that. Otherwise, do whatever you want to do. So what I'm going to do is graph points, and then I'm going to label my x-axis. Now that may seem out of order from how you've normally graphed things, but I've found that it makes my graphs a lot easier to actually physically graph, and I don't have to do any crazy math. So if I were to label my x-axis first and lay down like, okay, that's 2 pi, and try to figure out that function between it, it makes it a little bit messier. So this is how I do it. So here's what I do. I know that sine starts at the origin, and then its next big tick box goes up to its highest point. Its next big point comes back down to the x-axis. The next one after that goes down to its absolute min, and then it goes back to the x-axis. So I connect these curves, and I actually have one cycle of my sine function. Now you can either start to label your x-axis here, or you can continue and make another cycle. I'm going to continue and make another cycle, and then we'll label our x-axis altogether. So again, starting point, kind of like the origin or on the x-axis, goes up to its highest point, comes back down, goes down to its lowest point, comes back up to the x-axis. So now it's time to label our x-axis. So essentially what I do is I figure out, all right, if this is one cycle, it completes that, or its period is now pi, it completes one cycle in pi, so that point right there is pi. And so if I add another pi to it, that one over here is 2 pi. And in between 0 and 1 pi is pi over 2, and in between pi and 2 pi is 3 pi over 2. And so what happens between this 0 and 1/2 pi is pi over 4. And so here are the rest of the values on my graph for 2 complete cycles. Now the only other thing that I have to do is label 5 key points, and so I'm going to take the first cycle because that's always a little bit easier for me. And so it's going to be that point, that point, that point, that point, and that point. So let's label them and call it a day. All right, so here are my 5 key points labeled, and that's going to do it for this problem. And let's do one more graph, and then we can like officially call it a day on this video. So here we have a negative cosine function. So we took a look at that a couple slides ago. We determined the amplitude to be 4, and here's where we're going to take care of that negative 4 within the graph. And then the period, remember, was 4 pi because the frequency is 1/2. It's going to complete half a typical cycle in 2 pi. So it's going to take a little bit longer to complete 2 full cycles than it normally would. So notice that I have my same labels here. I go from +4 to -4, and I'm going to chunk this up in like groups of 3. And now let's graph our points and then label our x-axis last. So the first thing that I have to consider before I plot points is that this is a negative cosine function. So remember, sine starts at the origin and goes up and then down, and normally positive cos starts up at whatever its amplitude is and goes down. It makes that U shape. But when it's negative, that means that it actually starts from its quote-unquote negative amplitude. It actually starts at that number, as long as the midline is the x-axis. So remember, the midline will change things. But here I have a negative in front of my function. So if you remember back to transformations of just regular functions, if you're negating this y value here, remember because that's x, so this is negating the y, it flips it over the other axis. So a negative y means you flip over the x-axis. So that's what we're doing here. So we're going to start at the bottom, come up to the x-axis, go up to its maximum, come back down, and then come back down to its absolute minimum. So instead of being a U shape, it's going to be more like an A shape or an N, depending on how you like to look at it. So let's connect those, graph 4 more of those same points, and then we're going to label our x-axis. So I connected this curve, and then I started down here, and I went back up and came back down. So just repeating the same pattern. And now let's label our axes. So y-axis is taken care of, thankfully, and now it's just the x-axis. So remember, like in the sine function, I went, all right, if this is a full cycle, then this is the length of the period. As long as you didn't shift it either up or down, you're good. So if the period is 4 pi, this whole cycle is a length of 4 pi. So this point right here has to be 4 pi. And so if this is 4, then a complete second cycle would end at 8 pi. And so half of 4 is 2, and half of 2 is 1. So you're counting by pi in each of these little notches, which is awesome. So pi, 2 pi, 3 pi, etc. Now let's label 5 key points in the first cycle, and then we'll be done. And here you have our 5 key points in one cycle, and now we're done. All right, that's going to do it for this video. Thank you for watching.